Actually, I already did it, so turn the thing around. Let's see how it came out. Again, it's easier for me in Excel to just use midpoints. But, let me show you the classes and stuff. This is what I got for my classes. 58 through 60, 61 through 63, so forth. When you get a class width of 3, the freaky thing is each class is going to look like it's 2. Where do you see the actual width? Between the endpoints, right? 58 is the first start. 61 is the start of the next class. Those are 3 apart. Is that cool? Okay. So I'm just setting up the classes. I'm just setting up the stuff that tells me how to count my data. And then I count from 58 to 60. I saw 4 people that were within there, so forth. I saw most people got that 4, 7, 12. A few of us started at a different number, but your numbers looked right. So I didn't want you to redo it. Don't worry about it. You have, in general, you can pick how many classes you want to use, and you can pick which number you want to start at. So that's why there's a lot of flexibility, and that's why people misuse that, and they keep doing it until it looks closer to what they want it to look like. So they're fudging the data. Not generally a good idea. So your shape should be something like this. Just for some reason, there's not a lot of taller females. There are a lot right there in the middle. So it starts to look like it's going to be normally distributed. It goes up, and then it goes way, way down. Is that cool? Yes, sir.
So we use the heights of male and heights of female to combine to create.
Yes, exactly. So then I have the heights of men. Sounds like a very boring movie. Follow-up to City of Men. So here's the heights of men. So it's sort of the same thing, just in reverse. From this side, it looks like, and then it just drops down pretty quickly. And then when you combine those two, you get that purple one in the middle. So we see that it's called a bimodal. It's a 2-peak thing, a bimodal distribution. It's got 2 peaks to it, and that normally means that if you tease out, you might have 2 different populations. And here it's evident. It's men and women. And when you tease those out, they look a little more normal each. How are we doing with that process? Not too difficult. Just got to get used to it, right? Okay. Oh, let me think. Did I have anything else to show you? No, I think that's it. Okay. So, what I want to do is I want to show you how to use that calculator to sort things. Normally what I'll do on a test or a quiz is I'll give you a set of data, and it's normally real data. So like on your first test, I'm probably going to give you all the quiz 1 grades for everybody in the class. And then you'll make a histogram out of it. And the histogram probably should be roughly normal, but it doesn't need to be, right? So that's definitely going to be a test there. You know exactly a test question. Right. If you just talk to everybody, you can do it ahead of time, get everybody's grades. Why did I just say that? I might use last year's. I don't know. We'll see. But I just want to show you. Oh, which one was it? There you go. Cool. When I give that stuff to you, I'm not going to have it in order. Because the very first part is statistics, and the worst part of statistics is just working with raw data. Data does not come to you sorted. When you turn your homework in, it's unfortunately not already in alphabetical order. Shit. So then I have to do something. So thank God, if I give you 80 data points, you do not want to do that by hand necessarily. It's going to take a while. I'd rather let my expensive-ass calculator do it for me. Make it larger. Whoa. Okay. So let's all do this together. Probably the most important button on this thing for this class is more than likely the button that says Stat. I love it. It's crazy. So actually, we're never going to use that number. If you hit Stat right now, hit Stat. right there, right in the middle. Pop. Right, it comes up with, looks like something that was made in the 1980s. I know. It's a dot matrix kind of thing, but you got edit, you got sort. That sounds good. I want to sort some stuff, but I haven't told the calculator any damn data yet. So the calculator's not going to know what the hell to do. Clear list, that sounds exciting. Go to edit. Hit enter. So you can either, in general, when you have lists like this in this calculator, I can either hit the number 1. Like if I hit the number 5, it would do this setup editor thing. Or I can scroll around and hit enter when I get there. So if you hit edit, it should come out like this. So everybody hit that edit key that's playing along with me. Does anybody have something that does not look like that? Let me know right now, because that just means... Oh, don't worry if there's stuff in it. Some of you guys might have stuff in it. But does it have L1, L2, L3? Yes. Is everybody there? Yes, me. Oh yeah, you got stuff, don't worry. But you got the L1, L2, L3? Okay, first thing, let's clear all the data out. So if I had a bunch of crappy data in there, somebody else is doing, who knows these people? The quickest way to clear it is to go up to the list and then hit clear. Do not hit delete. If you hit delete, let me see if this does it. L1 is gone, right? And you go back in and it's still gone, it's just gone, and people freak out on the test and they don't come up and ask me, and later they tell me, my list 1 just went away, didn't it? Just come up and ask me. That's when you use that setup editor. Go to stat, number 5. If anything freaky is in your list, you're borrowing a calculator, and it doesn't say L1, L2, it says Frank and Bill, and it says weird shit. Go to setup editor, enter, and then when you go back in, everything's back to normal. What's really cool is the data didn't even go away. In case you delete something accidentally, your data's still there. I just don't want the data there, so I use clear. Go up to L1, hit clear, enter. So if you got stuff in L2, L3, and you don't want to look at it, just go to L2, clear, L3, clear. How are we doing so far? Not too bad? Okay. So let's all put some data in there. Let's put 8, -2. See, here's your, and real quick. So you see how it looks like there's 2 negative buttons? There's your negative button down here. And then there's a minus button right there. I'll get a laser. Watch out. Negative button there, the minus button there. So the negative button means negative, and the minus button means minus. So minus is subtraction, negative is a negative number. If you use them in the wrong place, the calculator is going to freak out. So if I right now put in there, -2, the calculator's like, what the hell? So you get a lot of error messages that can happen. This is one of the best. If you get an error message and it says go to, that kicks so much ass. Because if you go to, it'll actually put the cursor on top of the problem. See there? That's so awesome. Right? So if you're a computer programmer at all, that'd be awesome if they just would go right to the, sometimes it does. But you can make that into a negative instead of a minus. Now it has no problem. It's just hardwired differently in the calculator, those 2 buttons, negative, minus. So we got 8, -2, 14, 55, 0, 3, 3.2. Yeah. So 8, -2, 14, 55, 0, 3, 3.2. Everybody's got all that in there? So it's obviously not in order. It's a very small list. I could do that by hand, but I just want to show you how this works. So if you go to stat, what do you think the difference is between those 2 sorts? Let's go to A.
Ascending and descending.
I love it. So the A is ascending from smallest to biggest, D is descending. So let's do ascending, number 2. Hit enter, and it's got that sitting up on the screen. But of course, see how it's asking you a question. Sort what? What do I want to sort?
L1.
List 1, I love it. And see where your lists are. See above the number 1? You see that little For you guys, it's probably a yellow L1 above the number 1. For me, it's a blue L1. Yes, ma'am.
Mine doesn't say setup editor and done, it just says sort A.
Oh, it doesn't have that last stuff?
Yeah.
Weird.
All that?
Which one do you have?
The TI 83 Plus.
Really?
No, I think it's talking about the screen.
Yeah.
But you mean back...
It's because you didn't clear that. You didn't.
Oh, you mean here? Oh, I thought you mean you didn't have the setup editor option at all. Okay, good. Okay, thank you. Yeah, I did that earlier, so that's why it's up there.
Oh.
So everybody do this. Your the second button up here, I think for most of you guys is going to be, oh, it's blue, like me. I like it cool. It makes this easier. So that blue button, if you push it, it's like a shift key. And I just remember the days when I used to say on a typewriter. The shift key on a computer. So if I hit second, see the little arrow? And then I hit 1, so now it's going to do the blue above the number 1. That's how this calculator could do like 18 billion things all in the face of it, because it's got each button means 3 different things. And now if you hit enter, it's a little bit anticlimactic. Done. Right? So you go back into your list, and now it should be in order. So that's kind of nice, right? So when in your homework, when you have like data sets of 50 numbers, do that. Let me show you right now, since we got this data in here, let me show you a couple things. Yes, ma'am. Oh, cool. Let me go to edit. That's right. So in general, when I say go to your list, you hit stat, edit. So when I say go back to your list, stat, edit, get you back into your lists. Now here's something kind of cool. This is not quite as nice as Excel. Has anybody ever used Excel spreadsheets? You can have a whole column. You can say, I want to make this column the square of this column, and go forward. Right? So here we can do the same thing. I want to make list 2 the squares of everything in list 1. So how the hell do I do that? So if I do that right here, if I say second 1, L1 squared, my calculator freaks out. Because I'm trying to put a whole list into one spot. But if you go up to L2, it's going to say L2 equals what? And then it can say L2 equals L1, second 1 for L1 squared. And now I got all the squares of all that stuff. So that's going to come in really handy very, very, very soon. We're going to be doing this stuff a lot in the calculator. And normally what I want you to do is take what you have in the calculator and put it on your test. So I'm not going to give you 50 data points or something crazy. But it's a lot quicker to do this in the calculator than it is to do each one. What else can I show you? Go to stat again. Now obviously a huge part of statistics is not just entering data and sorting data. Right? But that's normally those summer jobs. Make money working from home. Your data entry. The next level that's a little more interesting is analyzing the data. So what's the most immediate thing that you normally think of when somebody says analyzing data, doing statistics on something? What's a quick thing that's a statistical thing you can do with a set of data? What's something I can calculate? Average. I love it. So where it says calc, if you hit the over button, you get all kinds of weird stuff. We're going to be using, let's see, on this face, 4 of these things. Well, 3 of them, really. The very first one is what I want to use right now. It's one variable statistics. So we only put one variable in, right? We just put one list of numbers. That's one variable. It goes from -2 to 0 to whatever the hell else I did. Do the 1-bar stats. Now, it defaults to list 1. If you want to use another list, you have to actually tell it, list 2, list 3. But if I just hit enter right now, it's going to just look at list 1. And actually, I decided just now not to talk too much about this, but this is, I'm going to come back to this again. That very first one is actually the average. And the way you say that symbol which is the way your gut probably would tell you to say the symbol, is X bar. Right? It's got a bar on it. So the math people went, let's call it X bar. Anybody know what that symbol is here?
Summation.
I like it. It's the summation symbol. It's a Greek letter S, capital letter S. So the math people said, we got to do summation. It's got a letter S in it. Hey, let's use Greek. Let's make it look really formal. And so there we go. That means sum up. So if I sum up all the variables I put in, I would get 81.2. That's going to become stupid useful, right? How do I calculate the average? Add them all up. Okay, there's add them all up, 81.2, divided by
How many are
the number. And there's 7 data points that we put in there, right? So that's how it came up with X bar. But it's used in other formulas for other things, adding up my data. So if I need that number, bam, I got it right there. How we doing? Okay. That's I think that's plenty. I went a little further than I wanted to, and that's good. If you've never used this calculator before, I think there's a couple of you that were that way. I think I added a new link. There we go. A while back, Grossman actually made some videos. So there's a new link on the website. It says videos created by Grossmont faculty. It's actually Irene Palacios. I don't know if you Irene teaches the online version of statistics. I would never teach that course because online is way harder than you realize. But I try to copy out, this is the kind of table of contents, because if you click this link, see how session 1 says basics? There's session 1. So if I click here, it'll actually pull up a video after you tell it what to open it with. And then it'll update shit and all that crap. After you do all that crap, it'll come up with a video. And it's really nice because she made it with something called Illuminate. And I can't remember if it's Captivate or what it is. But you can hear her, you can see what she's doing on the calculator. It's really kind of cool the way you can see. So you can see exactly what's happening with the calculator. The basics goes through stuff like how to do this, the problems we did earlier. Put the parentheses in, get it correct on the screen. And then she starts getting into statistical processes using the lists, stuff I just showed you. So it's actually really cool. So you can go there if you need to. How do I make it later? Don't worry. Maybe it'll open it. Oh, there it goes. Bless you. Bless you. Okay. It's teasing me now. Oh my god. Okay. After you've jumped through several hoops, if you want while I do it. Anyway. So your computer's volume is probably easier to understand than this one. So. Oh, there it was. Weird. Okay, that's enough of that. So that's there. That's something she did a while back, and I just keep forgetting to look for that link, so I finally did, and there it is. If you need help with that. So any questions over what we just went over? I'm hoping my calculator Bible, just keep it with you when you're doing homework. You can refer back to it, so you can do stuff in the calculator. What I want to do now is to finish out Chapter 2 and maybe even get into Chapter 3 a little bit. We'll see where we are with time.
Can we use the calculator Bible on quizzes and tests?
No, that's a really good question. No. So it's really to help you get the homework done and to get used to the calculator. And part of what I'm grading on the quizzes and tests is how well you're able to use the calculator. So use the hell out of it when you're doing the homework so you get more and more used to the calculator. And I am not a big, if you forgot how to do something, just come up to me during the quiz or test and say, I just want to make sure I'm doing this right, or if this isn't coming out right. Anything going weird with the calculator, just come up and ask me. I don't want that to be the reason you mess up. But you definitely need to know the basics on how to use this. Oh. All right. So the last 2.2 and 2.3 were the frequency distribution in the histogram sections. 2.4 is kind of the mass dumping of all the other ways you can represent data. We're not going to do every single method. There's some methods that just really aren't used all that much. So I'm just not going to do those. In section 2.4, we'll end up doing the dot plots, stem plots, and scatter diagrams. Those are the ones we're going to use. This is going to come back to us in chapter 10. But just creating a scatter diagram is your first step. And if any of you have taken algebra, which is all of you, you've all graphed x, y points. That's all a scatter diagram is. Right? In this case, it just represents, like at 8 a.m., it was 70 degrees. And at 9 a.m., it was 71 degrees. And so forth. And you just plot each point, and that's just like plotting x, y points. And then you can kind of see a pattern. For temperature, I'd expect it to be like that. These two are two that you might not have heard of before. And I think I'll start with the stem. I actually call it stem and leaf, just in case I say that. And this is a very quick way to get a visual of your data and to even sort your data if we didn't have calculators. So let's make some data up. Let's see. That's plenty. Okay. So let's use that data. Okay. So it started off looking like it was going to be sorted, and then I turned a corner, decided not to do that. Now here's what a stem and leaf plot is. Now let 2.4 be easy. It should be like, oh, please, Jeff, give me more of this. This is awesome. Unfortunately, we're not going to do too much out of there. But here's how a stem and leaf plot works. The stems are the first part of the number, and the leaves are the last part of the number. So I have these overriding categories. This data is in the teens, 20s, 30s, 40s. So that's my stems. 1 something, 20 something, 30 something, 40 something. That's my stem. And then the leaves come off of that. So somebody help me out. What comes off of 1?
11.
Yeah, so I would just put 1. So there's 11 if you put those together. Let's try to do this in order. So there's 11.
5.
Yeah, good. 5 for 15.
7, 9.
7, 16.
Yeah, we got 16, 17, 19. Cool. That's pretty damn easy, right? You guys semi with me? And then 20, 21.
4.
Yeah, 4,
5.
5, 5, 7, 8. 4, 5, 5, 7, 8.
8.
And then 38
8.
and 41.
1.
And there's all of our data. Cool. Now, if you turn your head like this, what does that kind of look like, almost? See again? Even better, yeah, histogram. So the bar graph equivalent for the histogram. The only problem with that histogram would be, what's wrong with that if it wants to be a histogram?
It's not normal.
It doesn't have to be normal. Histograms might be normal, but it totally depends on the data. It's not the histogram's fault if your data is not normal. What's the least number of classes a histogram can have? 5. And how many would this have? 4. So be careful. If I make you make a stem and leaf and it's only at 4, don't suddenly just turn it around and make it into a histogram. You gotta have at least 5 classes for a histogram. You with me? Sweet, cool. You see how easy it was to put everything in order? That was pretty quick. Instead of having to rewrite everything, that was a pretty quick way to put things in order. It shows you where the most things are, like a histogram would, so forth. Now the one thing, if normally people would just see this, they're not going to see the actual data. So they don't know if this means 1 means 11, or is it 115, or is it 1.1? So if my data was 1.1, 1.5, 1.7, my stem and leaf would look the exact same way. My stems would be this digit, and the leaves would be the decimal digit. You guys with me? So what I desperately need here is a key. Key. 1 means 11. Now the purpose of a key is to establish a pattern. Please, dear God, I've always had people that will do this for every single thing in here. And then I'm like, well, there went the whole purpose. You just need to say it once, and then it establishes the pattern. So 2, 5 means 25. So forth. Is that cool? So I could have data like, what you got, Jeff? 428, 469, 511, 642, 611, 709. What would my stems then be?
4.
Careful.
4.
4,
4,
5, 6. Now my stems represent the hundredths place, and then after that I could put 28, 69. So you just have a little space there, and your key is gonna, if you have a key, it's gonna alleviate any confusion. You kind of with me? And so forth. I mean, that's the way that works. So your key would say 428 means 428. Bam. Then they can read that off. Yeah.
Now, would you be able to do 42 in the stem section and then just do 8?
You could. It depends. This data is so far ranging that it would then have to be 42, 43, 44. You can't skip anybody because you can't make it look like you've included all the data. You want there to be empty spots. If there's going to be, so if you put 42, then this is going to be 43, 44. And do you see how far you have to get up?
Yeah.
So that's what tells me, no. But if my data was 427, 422, 439, 411, now that, it doesn't go very far. So I could use 41, 42, 43. Hell yeah. I love it. So there's a lot of flexibility. The key is what makes it clear to people when they look at it. I love it. Not difficult, right? Not difficult, just new. Yeah.
So 42 would be 0, 2. We'd be doing 400.
So if I did this,
Yeah.
so if I said 42, well, I'm sorry, it'd be 41, 42, 43. So this would be 1, 0, 2, 7. You guys see that? 0, 2, 7 coming off of 42. 9 coming off of 43. My key would say 411 means 411. Cool. Yes, sir.
What if you had a double-digit number that within your...
Oh, yeah. So if I had, maybe not this one, but maybe here I had 79, then I could have a stem that was 0. That's perfect. I love it. Now, some data is just not going to go into this well, in which case you just wouldn't make a stem and leaf. There's no point to it then. But if the data is kind of set up so that it goes into one of these well, it's a really quick way to make basically a histogram really quickly. Right? Not bad. Very simple. Hopefully. It just takes a little getting practice, getting used to it. Yes, sir.
Can you use commas?
Say again?
Commas? Separate commas?
Don't use commas. Yeah.
Can you though, or no?
Could. Just don't. Should be the key should make it clear. You shouldn't need to. That would be a little cluttered. Okay. So that's stem and leaf, what the book calls stem plots. All right, I like the idea of stem and leaf. It goes right along with how you set it up. Bless you. A dot plot, crazy enough, is something involving plotting dots. Sorry. Math people very often they're not very creative with their naming, but they are creative with walls of whiteboards. Okay. So a dot plot gets a little bit stranger to make some data that'll work well with this, but let me see if I can do it. I'll make it nice and simple here. Okay. So a dot plot works really well if you have a lot of things that are repeating. Because the basic idea of a dot plot is yes, Jeff, you have a sentence just hanging there. Basic idea of a dot plot is you put a dot every time a number is represented, and then you just put a dot over that if it shows up again, and so forth. So again, it's sort of like a very quick histogram in a way. It's not really making classes now, though. But so, for example, 1 shows up once, 2 shows up once, 3 shows up once, 5 shows up 1, 2, 3, 6 shows up 1, 2, 3, 4, 5, 7 is twice, and 10 is once. You can see this is really, really roughly normal, very roughly normal. It's a very small sample, so I don't know. But so far it looks like it might be. Starts low, goes high, comes back low again. The sample's really tiny. When you get to this section, they're going to ask you, what can you tell from your graph? And one thing you can always look for is, does it look like it's normal or not? And you can say here, you can say it's roughly normal, looks roughly normal. Starts low, goes high, goes low. How do you feel about that? I mean, that's stupid simple. That's really nice, very quick visual. We always want to figure out, is there a quick way to visualize my data? Okay. And scatter plot. Well, let me give you my example that got me this job. It's funny. I don't know how this is going to make you feel about me as a teacher, but when I applied for this job, I had to send them a videotape. And that was way back when I didn't, there were no smartphones. I don't know, some of you guys are like, there were no smartphones? What the hell did you people do? So I had a camcorder in the back, right? Tape in my, I was doing chapter 10, which I told you the scatter plot's going to show up again. And I talked about, let's talk about if you have a 7 a.m. class the next morning, you have a test, and the night before you go out and you have several beers. How would that affect your performance? So, number of beers consumed versus grade. By the way, this is not an endorsement of any kind of experiment. Okay. Don't consume this, but don't say it's because Mr. Waller said you have to go and try it out. So let's say if you had, a couple beers, maybe make an 82. Somebody always complain, if you had 4 beers, you get like a 70. You can have the guy get 5 freaking beers, but he still makes a 93 because, it's not, he can hold his liquor and he knows his shit. And then you got the guy that didn't have anything, and makes a 60 because he doesn't understand the damn thing. Who cares how sober he is? Or she, I don't know. And then 3 maybe is 75, and then 1 beer is 87. Who knows? But then all you got to do is plot these. This is X, Y, X, Y. Right? You make a good graph, like I told you. The scale's got to be consistent. It doesn't follow your data. It lets your data have a place to go. So what kind of scales could I use to plot this thing? And what makes sense? What should be the x-axis? What would make sense?
Grade.
Beers, actually. Normally you think of our x-axis as what we control and our y-axis as the output. So I can certainly control how many beers, well, depends on who you are, but you should be able to control how many beers you drink. And then you just see what happens with your grade. Right? So this is very often this is considered the independent variable. This is maybe some of your algebra teachers called it that. And this is dependent on that. So the same kind of thing happens here. Sometimes we don't know which way it is, so it doesn't really matter which way you put it. You'll still see the relationship. So if I plot this, here this is easy. 1, 2, 3. It's easy, Jeff. You can make it 4, 5. This is the number of beers. And then grade. What should my grade axis maybe be? You don't have to start at 0, but it does have to be consistent after that. Consistent? Yeah, maybe start at 60, 70, 80, 90, 100. That looks good. Officially, there's this little symbol. I can't remember if I showed you guys, like a little heartbeat. It's like a break in the graph. It's just saying, I'm not cheating. It's just nothing is there to look at, right? You just get up to where the data actually is. So 1 was a 87. So roughly there. Let's see, 2 is an 82. 4 was a 70. 5 is a 93. 0 is a 60. And 3 is a 75. So if you ignore those 2 outliers, this is the guy that no matter how little he drinks or whatever, he's still going to do horrible. And this is the one that can just really, he's been drinking beer since he was 3, and he knows statistics really well. Look at the people in the middle. The general trend is down. Again, who knows? I don't know if this study's ever actually been truly carried out. Well, it's carried out every time there's a test, I think, but I don't know if anyone's ever actually recorded both sets of data before. You can see there's sort of a line that goes through those. So that's chapter 10 is going to be talking about, can we fit that data to a line and make predictions about what would happen if you did this or that. I'm ignoring my outliers, though. But you can't always do that. You have to give really good rationalization as to why you want to ignore those. But we don't even have to. In this section, all you got to do is plot the points, step back, and they're going to ask you, can you see a pattern? Can you see a trend? Just tell them, yeah, I see a trend that looks like that. I see a trend that looks like that. Or I don't see a trend, they're all over the damn place. That's all you got to say. Chapter 10, we're going to start analyzing it more like that. Is that cool? So that's plotting X, Y points on a graph. That's silly. But now they definitely have real-life physical meaning when you plot them. Okay. Is there any questions about that? All right. So somebody told me I talked about beer. That's why they gave me the job. So. Oh, good. Not for my teaching ability, but because I talked about beer. I like that. The nice thing about 2.5 is we basically already talked about it. I thought I was in chapter 1. This is the one where the men and the women where the scale was bad. We talked about that last time. So I talked about it already. That's section 2.5. One thing in section 2.5 I didn't talk about last time was, can somebody tell me if I have a cube that is 1 by 1 by 1, what's the volume of that cube right now? Let's say this is 1 inch. What's the volume of that? Good, 1 cubic inch. In fact, it's kind of like the definition of a cubic inch. An inch cubed, right? So cubic inch. If I double all the sides, does the volume double? No, if I double all the sides, what happens to the volume? Now it's 8 times as big. Holy crap. So if I use 3-dimensional objects to represent, so for example, maybe this represents, they say, in 1 year, the taxes were this. Taxes, let's say, this is 1988. And then they say, okay, taxes in 1994, if any of you know your political history, this was, this happened. Well, that's probably not true. Maybe they're trying to say that it's twice as much as it was, but really when you use this image to say it's twice as much, you really are saying it's 8 times as much. And somebody argues that, no, you're overstating, and like, no, I just doubled the size, so it's twice as much. And you say, no, it's 8 times as much. You're crazy. You guys got it with me? So a little thing about you can't use 3-dimensional objects to represent stuff like taxes. Taxes aren't 3-dimensional, right? Okay. So section 2.5 really is just, can you take this horrible representation and make it better? Can you fix the scale, like the men and women disparity? Can you fix the scale? Can you just redraw it so it's not 3-dimensional and make it look a little better? That's what section 2.5 is all about. How are we feeling so far? I'm not trying to speed through this, but I do want to get into chapter 3. Because chapter 3 is where you really start to sink your teeth into it. Chapter 1 and chapter 2 are just getting us ready. Chapter 1 was awesome. It was definitions, just more and more definitions. Chapter 2 is, how do I just represent data? Straight up. Not even work with it, just represent it. Okay, here's what I saw. Now the rest of the semester is going to be, how do I actually work with the data? And can I say stuff about the data? What's the data tell me? Can I prove stuff with the data? That's going to be the rest of the semester. So, what I like to do is, the formulas we're going to see right now are very simple. So it's a really good way to introduce the symbols. And you already looked at a couple symbols off of the calculator. But that's really, I think I told you the first day, what gets people down about statistics. It's not word problems. It's the Greek symbols and the different formulas you can use. And sometimes you use that formula, but then you tweak something in it. So it's the concept. It's a really heavy concept class. At the heart of it, you just plug in numbers into a formula, but which formula do you use? Are you supposed to tweak it in this situation? You got to know what the situations are telling you. Right now, we're just going to build up the basics. We're going to look at section 3.2 is all about something called measures of center. Let me ask you this. How many of you guys actually look at the newspaper in some form? Even if it's online? You actually look at the paper? 5 of you? Okay. How many of you guys watch news and they show like graphs every now and again and stuff? Okay, a few more of you guys. Have you watched The Daily Show? Please. All right. It's actually not a bad source of news. So when they're talking about the housing market, when they're talking about home prices, have you guys noticed the numbers, what they represent? They don't say the average home price is now this. They say something else. Right? So this is what I'm talking about. This is why this is plural. In statistics, when you say what tells you what the center is, people very often just think average. And actually that word is a little misleading. We think we're going to use a more specific word because the word average could mean several different things, to be honest. So what we consider the average is actually really what's called the mean. And that's what we normally consider to be the average. It isn't because math people like 4-letter words that start with M, so they said average, make it mean. It's that the word average could mean several different things. And they also like 4 letters. So somebody tell me in English, what's the formula for what we consider the average? What's the formula for the mean?
The total number of things divided.
I think I heard add them all up.
Yeah. Divided by how many are there?
I love it. Divided by how many numbers there are, right? So the mean is I add them all up. And I know means all the data points. Add up all the data points and then divide it by how many there are. You with me? That would be the mean. So let's formalize this a little bit. The mean, I already told you what symbol we're going to use for that. And it's really because what symbol do we use for What symbol do we use for the data? What symbol will represent all the data values? You notice in algebra, what symbol represents a lot of things at once? X. So X. What symbol represents add, sum? I appreciate that, but the symbol itself, the Greek letter something, because it's sum.
Sigma?
Sigma. So that means sum up the x's. Right there by itself, that means sum up the x's. That's the mathematical way of saying add up. You with me? I know my grammar's awesome. This is why I don't teach English. And then crazy enough, the letter we use for the number of data points, and we already saw it on the calculator, is n. N always means the number of data points you're working with. So n. And the symbol for mean was x with a bar in its head. Right? This is called x bar. This is uppercase sigma. If you ever hear me say sigma, that's what I mean. Later we'll see lowercase sigma means something entirely different. And it's just not a little e. It's something else. We'll see that later. But that's our first little formula, and it's actually nice because this is a really good illustration of a formula almost always makes it look more difficult than it is. And it's not because we enjoy making things look more difficult. It's because a formula's got to capture an idea very quickly. It's shorthand. If you've ever seen real shorthand, it's some gobbledygook, right? If you don't know what you know the people that sit in courtrooms, stenographers. They're keeping track of what everybody says. They're not able to type all those letters that quickly. They have a little shorthand, the little symbols that represent things. If you don't know what those things mean, it looks like... So this is our first little foray into, I know how to get an average. It's easy. This captures the idea. I just have to be able to translate what it's saying to me. Right? We're going to get more complicated formulas. I want you to be able to read them in English. Right? That's because math, of course, is a foreign language. Okay, so how's that? It's not too bad. Took a long time to explain something we all already know. Right? But this is new, these symbols. But going back to what I was saying earlier, we don't use the average for home price. Why, especially here in San Diego, would that suck for somebody? How much does it cost to get a house down there? Well, the average house... Yeah, there's freaking $70 million houses. It's crazy. Go to La Jolla and just walk and just say, I'm a teacher, so I'm like, well, this is as close as I can get to these things. But, yeah, we don't make a lot of money. But if I took an average, it's sort of like if I went to a very small company, and Fred makes $35,000 a year, Bob makes $38,000 a year. He just started. Some other people make $50,000, $55,000, and then there's the CEO. Yeah, he makes. Well, let's not make it that. Let's say he makes $300,000 a year. And I got somebody new, some new guy. Here's the new guy. He's like, okay, I want to work at your company. How much on average do people make? Now, I'm not going to answer his question the way he asked it. I'm going to give him a better number. If I average those up, somebody help me out. How do you average those up for me?
95.6.
Sweet. And what does that really mean? Let's make this. This is in thousands, right? So it's $95,600. If I tell him you can expect to make, check out. It sounds about right to me, but you never know. Everybody stopped and then you said something. I think. Let me get it. Oh, screw it. You go. If I told this guy, oh yeah, we make $95,600 on average, like damn straight, I'm going to work there. That is evil. That's not right. So same thing with the houses. How much does it cost on average to get a house there? It costs about $1.8 million. I am not going to move there. Thank you. Bye. Right? So in reality, I want to use a different measure of center, and actually something that should be the first thing we think about, because I want to get the number that's in the middle. That's what it should mean. That's the center. So how many numbers do I have up here? 5. Is there a number that's right in the middle?
Yeah, 3.
50. And especially because my data is in order. If it wasn't in order, you have to put it in order first. Or else this thing could be whatever the hell I want it to be. I can just move the numbers around. Now it's 30. Yeah, no. This thing is called, what's in the middle of a road? Yeah, so this is called the median. And it's the number that's in the middle, the truly middle. And so in this case, it would be 50, which means I tell the guy, oh, we make about 50,000. So the word average actually pertains to this also. It's just that in English, we automatically think it means this. But the word average could actually mean either of these. So in the newspaper or the news source or the Daily Show or whatever you're looking at for news, hopefully something, you'll see the median for incomes, for housing, stuff like that. How are we doing? So you obviously want to use median when what's true? What makes the median the better thing to use? When you have what? Outlier, right? Anybody ever saw Children of the Corn? Outlander. No. So whenever I talk about, if you've ever seen it, you know what I'm talking about. If you don't, oh well. Okay. So far we got mean, we got median. Now a really good question would be, all right, Jeff, without flicking us off, you know that when I have 5 things, there's definitely something in the middle. But what if I had 4 freaking things? What's in the freaking middle?
2.5.
So if I had something like, well, the median. Here's the symbol for median, by the way. It's like he tried to be a mean, but he got his bar all crooked, so he just didn't make it. So the median in this case is going to be the number that's in the middle of the 2 numbers in the middle. That's pretty freaking middle, right? If it's in the middle of the 2 in the middle, it's in the freaking middle. So what's, of course, in the middle? Do it again, sorry. 17. So you just average these 2. I like it. So you really only have 2 situations. One is there's an odd number, sort it. It's the truly middle number. Or you got an even number of things. You have to add the 2 in the middle and divide them by 2. Average them out. Okay. How do we feel about that? That definitely should mean median to us. So here, find the mean and the median of these data sets I'm going to give you. Find x bar and x tilde. Yep. Oh, sorry. Bless you. Bless you. So of course for the median you have to be careful because they have to be in order. I like it. What do you guys get for the mean for this one? 50.3? Rounding it, roughly? What about the median?
48.
Good, because there's 7 of those, so something, whatever's right in the middle once you put them in order. So 48 sounds about right? Yep, okay, cool. And then this one's not too bad, but there's 6 of them, but it's a little weird. When you put them in order, you get 2, 3, 3, 3, 3, 6. So the median, let's just do the median first. It's 3. I love it, because you average 3s, you get 3. And the median is going to be, the mean is going to be
3.3333.
I like it because you get, let's see, 3, 5, 2 extra, yeah, something like that. 3 point, what now? 3 1/3?
Yeah.
Okay. Sweet. Not too bad, right? Okay. Good, so that's all I wanted to do today. I just want to get a little bit in chapter 3. Don't forget, we have that quiz through section 2-3 on Wednesday. I'll have the practice test for you then. Yep.
Do you use that Scantron or anything, or is it
No. My line on that is, if you have a math teacher that requires a Scantron from you, they are not really a math teacher. I'm not sure what they are. But if you can grade without seeing any work, you're looking at everything wrong. It's all right.
Just in high school, we always had to have Scantrons. They never did not have
It
them.
makes you go by quicker, the grading.
Yeah.
But
Some
it's
teachers
crap.
actually said like it was okay if you actually if it was okay to actually just do it right on the test. Other teachers, no.
I don't know, man. I don't like that stuff.